NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a classic problem using Newton's binomial theorem. The goal is to find the sum of the coefficients in the expansion of open parenthesis, a plus b close parenthesis to the n. Newton's binomial theorem says, open parenthesis, a plus b close parenthesis to the n equals the sum from k equals 0 to n of n choose k times a to the power n minus k times b to the power k. Here, n choose k are the binomial coefficients. To get the sum of the coefficients, set a equals 1 and b equals 1. Then every term a to the power n minus k times b to the power k becomes 1. So the left side becomes 2 to the n, and the right side becomes the sum of the coefficients. Let's see a concrete example with n equals 4. The expansion of open parenthesis, a plus b close parenthesis to the fourth, is a to the fourth plus 4 a cubed b plus 6 a squared b squared plus 4 ab cubed plus b to the fourth. The coefficients are 1, 4, 6, 4, 1. Their sum is 16, which equals 2 to the fourth. The coefficients are symmetric. In general, n choose k equals n choose n minus k. That mirrors the left and right side coefficients in the expansion. For open parenthesis, a minus b close parenthesis to the n, the coefficients are the same in magnitude, but the signs alternate. For example, for n equals 3, a cubed minus 3 a squared b plus 3, a b squared minus b cubed. For n equals 4, a fourth minus 4 a cubed b plus 6 a squared b squared minus 4, a b cubed plus b fourth. If we set a equals 1 and b equals 1, the alternating sum becomes 0 for any positive n. There is also a useful indexing relation used in many problems. If the kth term equals the rth term in the binomial expansion of open parenthesis, a plus b close parenthesis to the n, then k plus r equals n plus 2. This comes from the symmetry of the exponents when you count terms starting at 1. Here is the binomial expansion rule that generates the coefficients. It says open parenthesis, a plus b close parenthesis to the n equals the sum from k equals 0 to n of n choose k times a to the n minus k times b to the k. Step 1. Let's compute the sum of coefficients for open parenthesis, a plus b close parenthesis squared. First expand using the pattern a squared plus 2a b plus b squared. To get the sum of coefficients, set a equals 1 and b equals 1. That becomes 2 squared, which equals 4. Step 2. Now do open parenthesis, a plus b close parenthesis cubed. The expansion is a cubed plus 3 a squared b plus 3, a b squared plus b cubed. Set a equals 1 and b equals 1 to sum the coefficients. That gives 2 cubed, which equals 8. Step 3. Next is open parenthesis, a plus b close parenthesis to the fourth power. The expansion is a to the fourth plus 4, a cubed b plus 6, a squared b squared plus 4, ab cubed plus b to the fourth. Set it equals 1, and b equals 1 to sum the coefficients. That gives 2 to the fourth, which equals 16. Quick challenge. Can you predict the sum of coefficients for open parenthesis, a plus b close parenthesis to the fifth power? Pause and think. The pattern is 2 to the n, so the answer should be 2 to the fifth, which equals 32. Why does this work? When you expand open parenthesis, a plus b close parenthesis to the n, each term has some coefficient in front of a power of a and b, setting a equals 1, and b equals 1 turns every a power and b power into 1, so all terms become just their coefficients added together. Therefore, the sum of coefficients for open parenthesis, a plus b close parenthesis to the n equals 2 to the n. Recap. For n equals 2, 3, and 4 we found sums of 4, 8, and 16, and we predicted for n equals 5 the sum is 32. All of these match 2 to the n. We will solve a problem using the idea of the sum of coefficients in polynomial expansions. First, I will restate the problem, and then we will solve for n step by step. Step 1, understand the statement. We are told the sum of coefficients of the expression, open parenthesis, x plus y plus z plus t, close parenthesis, to the power n minus 3, equals 16 times the sum of coefficients of the expression, open parenthesis, a plus b, close parenthesis, to the power n. Recall a useful rule. For a binomial, the sum of coefficients of the expression a plus b to the power n is 2 to the n because we substitute a equals 1 and b equals 1. For a multinomial with m terms, the sum of coefficients of the expression x sub 1 plus x sub 2 plus x sub m to the power k is m to the k, again by plugging ones for all variables. Step 2. Compute each sum of coefficients. On the left, the expression has 4 terms, x, y, z, and t, so the sum of coefficients equals 4 to the power n minus 3. On the right, the expression has 2 terms, a and b, so the sum of coefficients equals 2 to the n. The problem states these are related by a factor of 16. So we write 4 to the n minus 3 equals 16 times 2 to the n. Step 3. Rewrite with the same base. We note that 4 equals 2 squared, and 16 equals 2 to the 4th. So, open parenthesis, 2 squared, close parenthesis, to the power n minus 3 equals 2 to the 4th times 2 to the n. Now, we simplify the exponents. Step 4. Set the exponents equal. When a power of 2 equals another power of 2, the exponents must be equal. So we have 2n minus 6 equals n plus 4. Subtract n from both sides to get n minus 6 equals 4. Then add 6 to both sides to get n equals 10. Therefore, n equals 10. Great work! Let us drop some confetti and then verify the result with a quick substitution check. Quick check. If n equals 10, the left side is 4 to the 7, which is 16,384. The right side is 16 times 2 to the 10, that is 16 times 1,024, also 16,384. Both sides match, so n equals 10 is correct. We are going to evaluate f of 1 for the expression. We'll also use a handy rule, that f of 1 equals the sum of the coefficients, and then verify by direct substitution step by step. Step 1. Substitute x equals 1 into f of x. Write f of 1 and replace every x with 1. Now compute inside the brackets to simplify numbers first. We get 1 to the 99 plus 1 to the 6 plus 3. Step 2. Use the fact that 1 to any power equals 1. Now simplify the expression fully. That gives us 1 plus 1 plus 3. So f of 1 equals 5. Great job! Quick challenge for you. Try evaluating f of 0 using the same substitution idea. Pause if you need a moment. Now, let's reveal the steps and the result. Plugging in x equals 0 gives left bracket 2 times 0 squared plus 0 minus 2, right bracket to the power 99, plus left bracket 2 times 99, plus left bracket 2 times 0 cubed plus 0 squared minus 1 right bracket to the power 6 plus 3. That simplifies to negative 2 to the power 99 plus negative 2 to the power 6 plus 3, which is negative 2 to the 99 plus 64 plus 3 equals negative 2 to the 99 plus 67. In this lesson, we will solve for n using a binomial coefficients condition. The context is that in the expansion of open parenthesis, a plus b close parenthesis to the power n, the second, third, and fourth coefficients form an arithmetic progression. We will translate that into an equation and solve step by step. If the second, third, and fourth coefficients are an arithmetic progression, that means 2 times the middle one equals the sum of its neighbors. On the binomial row, those 3 coefficients are n choose 1, n choose 2, and n choose 3. Let's sketch a small portion of the binomial row, and then write the arithmetic progression condition as 2 times n choose 2 equals n choose 1 plus n choose 3. Step 1. We write the given relation using factorials to make simplification easy. Recall that n choose k equals n factorial over k factorial times n minus k factorial. Substituting into the equation gives 2 times n choose 2 equals n choose 3 plus n choose 1. Step 2. Simplify the factorials. N choose 2 simplifies to n times n minus 1 over 2. N choose 3 simplifies to n times n minus 1 times n minus 2 over 6. And n choose 1 simplifies to n. So our equation becomes n times n minus 1 equals n times n minus 1 times n minus 2 divided by 6 plus n. Now multiply both sides by 6 to clear the denominator. Step 3. Move everything to one side and expand. Expanding and simplifying leads to n cubed minus 9, n squared plus 14n equals 0. Now factor the polynomial. Step 4. solve and check validity. The roots are n equals 0, n equals 2, and n equals 7. But in the original binomial problem, we need the second, third, and fourth coefficients to exist and be non-zero, which requires n at least 3. Therefore, n equals at least 3. Therefore, n equals 0 and n equals 2 are invalid, and the acceptable value is n equals 7. We will find the sum of the coefficients of the polynomial raised to the sixth power by using a very handy rule. The sum of coefficients of a polynomial f of x equals the value of f at x equals 1. Here is our expression. 4x cubed minus 2x squared plus 3x minus 7, all to the sixth power. Step 1. Substitute x equals 1 into the polynomial. We compute f of 1. That is 4 times 1 cubed minus 2 times 1 squared plus 3 times 1 minus 7, all to the sixth power. Simplifying inside the parentheses gives 4 minus 2 plus 3 minus 7, which equals negative 2. So we have negative 2 to the sixth power. Here is a useful reminder about powers of negative numbers. Negative a to the n equals negative 1 to the n times a to the n. Step 2. Calculate the power. Since 6 is even, negative 2 to the sixth equals 2 to the sixth, which equals 64. Quick challenge. Using the same rule, find the sum of coefficients of the expression, open parenthesis, x cubed minus x plus 1, close parenthesis, to the fourth power. Pause the video and try it. Now, we evaluate at x equals 1. 1 minus 1 plus 1 equals 1, and 1 to the fourth equals 1. So the sum of the coefficients is 1. In this lesson, we'll expand the expression, open parenthesis, x cubed minus 2, close parenthesis to the fifth power, and then find the sum of its coefficients. We'll also use a powerful shortcut to get the sum of coefficients very quickly. First, the binomial expansion rule. The expansion of open parenthesis, a minus b, close parenthesis to the n, is the sum from k equals 0 to n of n choose k times a to the n minus k times negative b to the k. This creates alternating signs automatically. Step 1. Expand open parenthesis, x cubed minus 2, close parenthesis to the fifth power using the binomial theorem. We'll write the six terms using the coefficients 1, 5, 10, 10, 5, 1. First, keep the powers of 2 unmultiplied, so we can see the pattern clearly. Now, evaluate the powers of 2. Then, simplify the x exponents. Step 2. To find the sum of the coefficients. Step 2. To find the sum of the coefficients, evaluate the polynomial at x equals 1. This works because every x becomes 1, so the value equals the sum of the coefficients. Let's plug in x equals 1 to the simplified polynomial. Then add the numbers. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.